Mongers, you can hear very little. That was a good way to start. Settings, voice, cancel. I know there's a thing here that lets me adjust volumes of things. And can't remember where that is. Cameraman, no, no, no. No.
What's that bar alongside on the right-hand side?
That's the control room, but it's not letting me modify the volume. Let me change the system settings. Doop, doop.
Is the volume not right beside that?
That's the volume of, not the microphone, no.
Okay.
Input. Audio codec, show volume in menu bar. Looks like it's picking up okay. Are you sure? Can you still hear it all there, Jim? Just barely. I'm afraid I don't have many other options right here. Modify pickup level of the mic. Are you sure? Oh, that's spoke up. Okay. Sorry, Jim. I'm not sure there's much I can do here. I'm hoping it'll improve, but anyway, thank you very much, Case, for giving the talk, and take it away.
All right. Thanks, everybody, for coming. I want to start off by thanking Dave for giving us the venue, and also Included for giving us the venue here, and for helping us out with organizing this yet again. We're hoping to give him a break from that, and hopefully someone will step up soon. But I want to thank him for all his help that he's put forth in keeping things going here. So a little bit about myself. I know this is the Perl Mongers, and I'm talking about Postgres, but I've been using Perl since sometime in the mid-90s. And I've actually been using Postgres since the late 90s. Back then it was actually called Postgres 95. We named it at some point. I've been a big fan of it for a very long time. I currently work for a company in France, and we heavily use both Perl and Postgres there, which is why I thought I'd come and show you guys some of the things that we use and how we access Postgres and how we use it. What we basically do is we gather a huge amount of data on an hourly basis, and then we analyze that data and generate reports on demand. So we kind of have both sides, but we need speed of data coming in and a lot of flexibility in generating complex reports out of that data. And pretty much everything that we talk about, we use quite heavily in our codes. So one of the reasons I wanted to talk about Postgres is because as Perl developers, we often use the tool that we know best. We use Perl to do our work. And some people might be tempted to pull the data into Perl to process it. Perl is fantastic at data munging. But I want to show you that you can do a lot of the things in the database and get Hit to do a lot of the work for you. At work last week, I was looking at a script that was one of the legacy scripts. We're actually rewriting a legacy software system that's been there for I don't know how long, a long time. We try not to look at the code too often because there'd be dragons in there. It's very old, Perl and PHP. But I had to look at a script that was generating some reports. And the nice thing is it was a Perl script, and it generated 7 reports, CSV reports, in one go, which I thought was pretty good. Until I looked at it, and the first thing it did was it ran a query, and it said, select star from this table where date is greater than 6 months ago. So that kind of surprised me. It's getting all the data for the last 6 months. I assumed it might not be too much. So I ran a count star on that query in the database, and after about 4 or 5 minutes, it came back with 15 million. So, and this script ran daily, and it processed 6 months worth of data that doesn't change except for one day. and pulled out 15 million rows every day, and then munged them, processed them in Perl, generated the reports, and then threw it all out, and did the same thing again the next day with one more day's worth of data. These are the types of things that we can do in the database instead of in Perl. 5 of those scripts, I was able to generate the CSV file with a single SQL query and have the database do all the work for me. The reports all had maybe about 10 lines in them, so it wasn't even that much to come out of the database. So that's why I want to talk about, make sure you use the database to do what it can do instead of pulling it all into code. So we'll start with looking at just the basic structure of a query. Simple select statement, you pull out some columns from a table, condition, maybe another condition, and you order it. You might throw a join in there to join 2 tables together. You might have a group by and do some aggregation of your data, and maybe throw a having condition in it. And that's sort of the basics of what a lot of people do with Postgres. If you're used to using something like DBX class, that's pretty much the limit of what you do if you use that system to get your data out. But Postgres can do a lot more than that. It has a lot of stuff that it can do. So this is sort of the basis of a select statement in Postgres, where the with query or the from item can be any of these things. The grouping element can be that, and the with query can be that. And there's more to it than that as well. That's just sort of the basis of what Postgres can do in a select statement. So there's a lot there that a lot of people are not using. So the first thing I want to talk about is the concept of a lateral subquery, which just came out in Postgres 9.5, and it was really cool, and it made a lot of our reports a lot easier to do. So at its basis, all it is a subquery that you can do, and in that subquery, you can use results from the outer query, which sounds like something that's pretty simple, but it's not supported by default by doing normal joins. So what it ends up doing is it allows you to do a for each loop over your result set with another query to add more data to your result set. And I'll show you some examples that make that easier. But let's back up and look at some simple joins first. I'm sure you guys all know this if you've been using databases, but our standard is an inner join. That's what most databases do by default. That means when you're joining 2 tables, your condition has to meet on both sides, and only the records where there's a record of both sides where the condition meets are included in the result set. An outer join means you get all the records in one side and all the records on the other side, plus where they meet, you get data as well. So if you have a record in table A and there isn't a matching one that matches the condition in table B, then the values from table B will be set to null, and the same in reverse. But you get a lot of data with a full outer join. What you'll more likely see is left joins, which means we get all the data out of our left table and all the matching records in table B. So that's sort of a simple way of looking at joins. So let's look at a bit of data to play with to show our queries. I've just got a simple users table, username and full name. Obviously, you'd have more data in there in a real application. And then we've just got a table with some messages, which is basically, it links to the username, the time it was posted, and a title and the content of the message. So pretty basic setup. And I've shown a little bit of data down below for each. So we've got some users, and they each have some posts, except for one of the users has no posts. That'll come into play later. You might notice that all of my character fields are text instead of varchars. Do you guys still use varchars? Or specify limits, say varchar 10, varchar 50? Because in the end, it makes no difference to Postgres. They're all text fields, so we don't put any artificial limits on it anymore. We just set them as text. Makes it easier. If you need a constraint on it, if you need to make sure that it doesn't get too full, then you can put a varchar with a number on it. But it's much easier to generally just use text fields because behind the scenes, it's all the same basically. So let's say we want to fetch all of the users and the last post that they posted from the database. So as a first try for that, we might do a simple join. So we're joining users and messages, and we're pulling out the full name and the title of the post. But what we end up getting is too much data. We're getting all of the posts or all of the messages that a user has ever sent, which is not exactly what we want. So we can do this using a correlated subquery. So now what I'm doing here is I'm using full name and I'm pulling out a subselect value. So in there, I'm querying the messages table and I'm saying, give me all the messages where the usernames match. I want you to order them by the posted value in descending order so that the first one or the last posted is at the top. And I'm going to limit that to only return one. And I want you to stuff that result in the field or in the column called title in the result set. And that actually works. So now we get a list of the users and the last post that they made. So that's not too bad. But what if we wanted the posted time as well, if we want more data out of it? So we want the title and we want the time it was posted. So you might think you can add that to your select query or your correlated subquery, but it doesn't work. It's going to return an error. It's saying that the subquery must only return one column. So we kind of hit a roadblock there. We need to try something different. So what you can do is do two subqueries in there. So now we're pulling out the title in one subquery and we're pulling out the posted in the exact same way from the second subquery. That works, but it's pretty ugly and it doesn't actually scale very well. So, and also, what if we wanted the last two posts from the users? We might throw limit 2 in there, but that also doesn't work. We can only return one row from the subquery that's used in an expression being right after the select call, where we normally put our columns. So we can't return 2 rows from that. So this fails if we want any more data from our messages table. So what we could try instead is do a subselect. So we're going to join from users, and then we're going to join a subselect table or a subselect query. And that subselect query is basically going to grab our messages, order them as normal, and then put a limit 2 on it. And it's got that where clause in there that says messages.username equals users.username. So it's trying to join this against something that's in the outer query. And that's not allowed. You can't do that. So you get an error saying, and it gives you a little hint there as well. It says that there's an entry for the table users, but it cannot be referenced from this part of the query. It's too far down in the subquery. A subquery is generally executed on its own, and then the results of it are provided to the parent query to use, not the other way around. So what have we discovered from this so far? A simple join gets too much data. Correlated subqueries work, but they look pretty messy. You can only fetch individual columns, but it doesn't work when we want multiple rows. And joining to a subquery with a limit clause also doesn't work. So what we can use to solve this is to use a lateral query instead, or a lateral subquery. And this is what it ends up looking like. It looks almost identical to the subquery that I wrote before. In fact, the subquery itself is the same. The only thing I've changed is that join is now set to lateral instead. And notice also that I've got a comma after users, and then lateral in the select statement. If you list your tables with a comma, by default that does a cross join or a full outer join. And that's actually what we want in this case, because we have this condition in here that says messages.username equals users.username. And previously that failed, but with the lateral subquery, that now works. You have access to the data that's in your outer query from within your subquery. And what we get is exactly what we want. We now have the user's name, we have the title of the post or the message, and we have the time it was posted, and we have the top 2 records for each user in one query. Now, if you normally did that in Perl, especially with DBX Clash, you'd be doing multiple queries to get all that. You'd get the users, you'd loop through the users, and then you would get the messages for each user. So you could end up sending a huge number of queries to your database just to get that information. When with a quite simple query like this, you can pull it out all at once and process it locally. Now there's one user that was missing there, the one user that didn't have any posts. So if we wanted that user as well, we normally would use a left join, and you can do exactly that with the lateral command as well. So we can do, notice the comma is missing now because we're doing users joining to this subquery. But we're doing a left join lateral of this, and we get Timmy back. So he's in there now as well, but he doesn't have any posts, so those values are null for him. The title and the posted is null. Does anybody have any questions on that?
TPM lives.
Yes. How can we improve this query?
James had a query on that one. He typed in, when was lateral introduced into PostgreSQL?
I believe it was 9.5, which everyone should be using. Actually, you should be using 9.6 now.
I actually already typed that one in there. Welcome. Thanks.
So can we improve on this query? It would be nice if we didn't have multiple rows. In our result set, the username is repeated multiple times. So parsing that in code can be a little bit frustrating or cumbersome where you're looping through your data. So what if we combined our data into a single row for each user, but still provided the information for 2 posts for each of those users? In Postgres, that's easily done by flattening it into JSON or munging those records into JSON. So what we've got here is pretty much the exact same query, except the highlighted portions are now different. We're going to group by our full name, and grouping means that we only have one full name coming out in our result set. And now we have this aggregate function in here, which is going to aggregate the rest of the data based on our grouping of full name. So for every record that has a unique full name, we're going to run this JSON-B ag. And what that does is it takes a result set and it puts it into JSON for us. And basically what we're doing here is we're telling it, I want you to order the results by the posted in descending order. And I would want to grab everything from the post result set, which is our subquery here. So everything that's returned by post is going to be munged into this JSON block. So we're going to get title and we're going to get posted in there.
Why do you do the order by clause in there?
Because we need to tell this function to do some ordering for us. So there's no point doing it in both places. So it's best to do it in here so that we are sure that the ordering is going to be done correctly, because that's what's going to put it into JSON for us. So it may work as well if you have it in the subquery, but I think it's clearer and safer to put it right where you're actually requiring the data.
It doesn't work reliably in the subquery.
I'm not sure.
It doesn't.
It doesn't?
It doesn't.
Okay. So this is the output that we get from that. So we have a single value for each user, and we now have an array of hashes with the title and the posted. And for mine here, there's 2 entries in there. So that is much easier to parse in your code. And in a lot of applications, especially if you're doing web applications, you can probably throw that directly at the front end and render that information on the front end. So depending on how you build your applications, that can save you quite a bit of time by doing that. Any questions on that?
That's awesome. Did not know about the aggregate function.
It's really powerful and really useful. So just a bit on the aggregate function here. If you specify only a column, it'll flatten it into an array. So here I'm doing JSON-B aggregate post.title and still ordering it. And that's going to result in an array, a JSON array of titles in order. If you specify, like I did in the query, post.star, which means multiple columns, it's going to provide an array of hashes with that information. So you've got both options there. You can't actually list multiple columns in here. You can only do post.star or a single column. So if post.star has too many columns in it that you don't want, you'll have to clean up your subselect so it only retrieves the information that you want in that subselect. Sometimes that means wrapping it once again in another select to just grab the information that you need. So you might have 3 levels of subselects, but Postgres will happily do that and work with that. There's another version of the JSON-B aggregate, which is JSON-B object aggregate, and that creates objects, and in this case, that means hashes. It works similar to the other one. In this case, what we need to provide is a key and a value. So we're going to put the post title as the key and the post content as the value. And what we end up getting is a hash with that information, title 1, description 1, title 2, description 2. So we don't have to do ordering here because it's being dumped into a hash and there's no consistent ordering in the hash.
If you have two post titles that are the same, will it happily just spit it out, and when you parse it, you lose one, or?
It will most likely just grab the last one and it'll ignore the others.
Okay.
So you need to ensure that post title is going to be unique. That's a good question. And there's also an alternate version of this where you can do post title as our key and post.star as our value, and that's going to create a hash of hashes for you. So it'll give us title 1, and then in here it'll have title 1, content, description 1. I don't know why I use description, there were messages. It should be message 1. Does that make sense? So that gives you quite a lot of power to take regular Postgres table data and return it as JSON with very simple functions, just creating subqueries and mashing it into a bunch of JSON for you, returning that to your code, and oftentimes pass that directly onto your front end. So you can keep your code lean and do more work in the database and on the front end.
Seems like it was custom made. Like you could really build
Absolutely.
huge things to pass to something like Angular or React or what have you.
Exactly, yeah. We do a lot of that. We use Angular at work as well. So everything is data and JSON blocks. So yes, there's definitely a lot of power there.
We got a question here. How is the JSON-B ag limits? How do you limit the rows for JSON-B ag?
Well, you have to limit it in the subquery itself. So you're basing this data off of generally a subquery, and in that subquery you can provide a limit to say only provide me this number of rows. If you don't do that, you can obviously get massively huge JSON blobs, and you can probably overflow the size of a column fairly easily. So yes, you do need to be careful that you know what data you're throwing into a JSON blob. Although I think with Postgres, I haven't looked this up in a long time, so don't hold me to it, but I believe a single value can hold up to a gig of data. So I think you're going to be okay.
Don't do that.
It'll do it, and your system will probably crash while doing it. So yeah. Does that answer the question?
Is that good, Antonio? Yes.
Excellent. So what we were doing there is aggregating data and returning it. So there's other ways in Postgres that you can aggregate your data, and it's usually done with the group by. So I've got some more different data here. I got some weather data, and I found some weather data from England, which I enjoy because they have funny names for places and stuff. So, so what we're doing here is we're selecting a region, grouping by that region, and then finding what the average temperature there was across our data set. And it returns some data for us. That's pretty straightforward still. Now, what if we want to group by another value? So we group by region before, but what if we also want to group by day and find out what the average temperature is for each day? We generally need to do that in a separate query. So you have to do 2 queries to get that information. But with Postgres 9.5 as well, they introduced a new concept called grouping sets. This is part of the SQL standard, and it allows you to group against multiple columns in your data. So what we're doing here is we're selecting region and day, and we're getting the average temperature of it. And normally we would have to group by region and day, which means we get the average temperature for a specific region on a specific day, and that's not what we want. We want them separate. So we have this concept of the grouping sets. So what we're telling it to do here is I want you to group first by the region and then by the day. And if you look at our result set, you can see that this row is grouping by Tuesday, And that was our highest average temperature across our data set. And then this one here is a specific region, which means we don't get a day because we're grouping by region in this one. So you get some nulls in different places, but you get all the data returned in one data set. Does that make sense to everyone?
Sorry.
So what's the first one without a region?
The first one without a region is grouping by day. So it's saying for all the Tuesdays that we have data for, give me the average temperature. And this one here is saying for this region of Southwest England, give me the average.
Oh, it's not that region of Southwest England on Tuesday.
No, we can do that as well. We could put a grouping set of region comma day in here as well. And then we would get all of those as well. Then we would have a lot more data because it would basically 7 times the number of regions of data. I've just done them separately, but I'll show a couple other examples where it does more. There's one more thing that we can do as well. If we specify an empty group, it means don't group by anything, which means you can get a total over everything. And if you look at the last one, no region, no day, which means our average temperature over the entire data set was 1.39. So we've now gotten 3 different sets of data in a single query. And by doing it in a single query, Postgres only has to make one pass through your data. Whereas if you do it in 2 or 3 separate queries, it's passing through that data as many times as you're doing queries. So it's much more efficient to get your data all in one go. It's less travel through the database, it's less load on the database, and you're going to get all your data much quicker.
So it's less load. I was just wondering that, like what the penalty is here in terms of indexes and when you do these grouping sets, how it handles, having to do this in the indices. And I guess basically the grouping sets in case of an aggregate, you're just creating 3 buckets instead of 1.
Exactly.
Okay.
And as it's passing through the data, it can add to those buckets as it needs to. This record has a region, it has a day, and it can contribute to the overall total. So it's doing more work, but it's doing it in one pass through the data. So if you're going through a million rows, it's better to go through those million rows once than to do it 3 separate times. You can do the same thing with a union. So you can do 3 separate standard group by queries and union them together. But again, it's going through your data 3 times to get it. In that case, you might as well just do them as separate queries.
It does seem to me it's more likely to be a full table search, and you're less likely to be able to just skim through an index and not.
Well, the index is going to be determined by your where clause, not by what your select statement is doing or what the columns that you're fetching or your expressions. So your where clause, which I'm not including here, so I'm basing it on the whole data, your where clause can restrict that and find those records quickly. We're just looking at the values and aggregating the values of the records we found. So it's no difference performance-wise in that sense. The only thing is there's a bit more memory because we, like you said, we have 3 buckets of information where we're tracking information. Does that make sense? So there's a few other things that we can do with this. There's some helpers that you can use. So here we've done a group by roll-up, and we're saying I want to roll up by continent, country, and region. This is how you generally use this type of setup. So we can get our aggregate data based on the continent we're in, based on the country we're in, and in the region, and we'll get it all in one go. So that's basically the same thing as doing this long form. So we're having 4 grouping sets. First, we're going to group by continent, country, and region. Then we're going to drop off the region. Then we're going to drop off the continent, country, and then we're going to drop them all off to get our total result set as well. So we're going to have extra rows for all of these. Each one of these sets is going to generate new rows for us. So if you have a million rows, that first one is, well, no, it depends on how many regions you have, I guess. So if you have 1,000 regions, you're going to get 1,000 rows there. If you have 50 countries, it's going to be another 50 rows. If you have 5 continents, is there 5 continents? Well, we probably won't have, well, we could have temperature for Antarctica. So we'll have another 5 rows and then 1 extra on the end.
Still the only data for Antarctica.
Probably. Just for one location though, right, in Antarctica. So that's what the rollup provides you. It gives you that whole structure of the aggregate data. There's some extra things that you can do with this that I haven't provided slides for that's kind of useful. What ends up happening if you group by continent, you know your country and region is going to be null in the result set. If you happen to have a continent that doesn't have a region, like Antarctica, it might also be null. So it would be hard to tell which continent was Antarctica with no region and which one was the total of Antarctica with a region. But there's actually ways that Postgres has to figure that out with extra parameters that you can put in your select statement to tell you what it's currently grouping by. So if you need that functionality, look it up in the docs. It's quite useful and quite powerful as well. There's one other grouping set that we can do, which is called the cube. And this basically does every combination of the values you've provided. So if we want to cube by region and day, it's going to do all combinations of region and day, which is both of them together, region on its own, day on its own, and no grouping.
That could escalate quickly.
If you had 3 values here, you'd end up with about 10 or 15 different combinations. So AB, ABC, AC, all of the different combinations. So yes, it can escalate very quickly. I haven't used cube ever, but I've used rollup a few times. So that's generally the more useful one. All right, sticking with grouping things together, we have the concept of window functions. Window functions allow you to group your data and your result set together as well, but as opposed to what a group by does, a group by reduces your result set. So you're grouping by region and you're only returning the rows for each region. What these window functions allow you to do is return the entire result set, but still do some aggregate stuff over different windows in your result set. Okay, so what we're doing here is we're retrieving the site, which is where the temperature is actually being measured, the region it's in, the day, and the temperature. And now we want to get the average temperature by region. So we use this over and partition by region. So this is going to get the average temperature for all rows in our result set where the region is equal, or where the regions are the same. And we're going to label that as by region. We're going to do the same thing for day, and by providing this empty one again, we can do the same thing for overall. And if you look at our result set, we can see in this region, we get, first of all, we get extra columns here, whereas in the grouping sets, we got extra rows. So it's sort of getting similar data, but it's providing it in a different way for us. So we can see now we have by region, by day, and overall, and most of these values are repeated. Specifically, the overall is repeated because that is the average temperature over our entire result set. It's going to be the same for every row. The by day, you'll see there's a few that are different. We've got Tuesday, 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 and then Thursday here. Thursday has a different average value over its result set. And the same with our region. So we've got the top 3 are the same region, and we've got, again, the same value for each of those. And then we have a different region has a different average temperature across it. But we're still returning the site. We're still returning each temperature that's part of that site. So we're aggregating over, we're breaking our data set up and running an average over that set. And now there's another set over here that we're running an average for, and another set over here that we're running an average for. And we're returning that in a single query. Now you do have a bit of extra duplication. If you're returning 10,000 rows, then you're going to repeat this number 10,000 times. So you need to use this in the right way, in the right place. If you're returning 1,000 rows, it probably makes sense to use something like this. If you're returning a lot more than that, you're wasting a lot of data by repeating those values over and over again. But this is just one application of window functions. There's actually other things that you can do with it. If we go back, do you guys remember the lateral query that I showed before, where we were fetching the users and we wanted the top 2 posts or the last 2 posts that they posted? And here was the results that we had. So that's the exact same query that we had before. We can get this data using a window function as well. It looks a little bit bigger, but what we're doing here is if we look on the inside first for our select in the middle, this is where we're querying the messages, and we're actually joining in here. So this is the main query here. We're joining users and messages on username. We're selecting the full name, the title, and the posted. And then we're getting this extra column as well that we want to get. And this is our window function. We want to call the aggregate function row number. We're not passing anything into it because it doesn't need anything. And we're partitioning it by username. And we're ordering it by posted descending. So what this is going to do is it's going to partition our user and message combination, our joined table. It's going to order our results by posted descending, which means we're going to get them in the right order. And now it's going to partition them by username, which means we're going to get little chunks of data for each user. So when my name comes up, I'll have 3 posts there that'll be ordered from in descending order. And it's going to assign a row number to each of those, which means that the first record that it returns is going to be 1. The second record it returns is 2. The third one is 3. And then the window ends, and we go to the next window, which is going to be Albert, possibly. And it's going to start that row number over, and it's going to be assigned 1. And now that window is over, and it goes on to the next one. And it keeps doing that. So what this row number is doing is in each partition, all it's doing is assigning a number to each of the records in there. Pretty simple and pretty basic. But what that allows us to do is in the outer query, we're selecting full name, title, posted, and num, which was this value here. And we can add a simple where clause that says where num is less than or equal to 2, because we only want those records that have been assigned a number 1 or a number 2. If you had more messages, they'd be 3, 4, 5, 6, 7, all the way down. They're going to be thrown out because we're constraining our result set based on that value. And in here, we can order by full name and num, because we know num is already ordered properly based on our posted descending ordering. And that gets us the exact same data that we had in our lateral query in a slightly different way. We don't need the num column at the end, but I've included it just to show you how it creates those numbers. So the first 2 messages for Ned Stark are marked as 1 and 2. He's a bit boring. He just says the same thing over and over again. Does that make sense, guys? Yes?
Were the posted times always all the same?
Yeah. I inserted them all at the same time.
Okay.
And I included a timestamp, a time zone timestamp, because I think everyone should use them. But it means my data is a little bit ugly. I might end up cleaning it up and do it just by date, because it does end up looking a bit busy there. There is actually millions or I think thousands of a second in there as well that I stripped off already. So they are different.
Okay.
So they are ordering legitimately, but it was more for display size that I turned that off. Now, personally, I like the lateral query better. I find it a bit simpler and easier to read, but there's a lot more that you can do with window functions than just these 2 things that I've shown you here. This row number is very powerful to get extra data out of other tables, and there's lots of other different things that you can do with it. Things to remember about window functions is they're applied kind of as the last thing in a query. So in the outer query, if you're doing, in the actual query that has the window function, it'll do any grouping if you have a group by in there. Any halving clause will be applied. Everything in the where clause, all the aggregates will be calculated, and then the window function is going to apply on that resulting data set. So if you do a group by, you're already reducing the set of data that the window function can apply to. So it's something to keep in mind when you do that, when you combine those things. But it's certainly possible to do that. Group it down to a specific set, and then have a window function that partitions that into different blocks and applies another function across You can do multiple window functions in the same query. There's nothing stopping you from doing that, as we showed in the first example. And there's lots of other functions specifically for window functions that are there. I've listed a couple of them here. There's many more that do different types of things, different types of things that are applied to your partitions.
How easy is it to get information out of Postgres about how much work it's had to do in a particular explain?
Yes, you can use explain on any query and it'll tell you exactly what it's trying to do to get your data set. And if you change your query slightly and run another explain, it might completely revamp it. The other thing you can do is you can run explain analyze, and it'll show you the time it took for each part of the query and where it's spending the most time. It'll try to give you how many rows it goes through. So you might be fetching 10 rows, but it had to look through 1 million of them. And that's where you might want to create an index so that it doesn't have to do sequential searches or different things. But making small changes to a query can have a huge impact on how efficient it is.
I imagine most of it related to the I/O, that you do a huge amount of processing internally.
Yes. Yeah, exactly. And something else on this query here, in this subselect here, if your user has 1,000 messages, it's generating a subselect, and each user is going to have those 1,000 messages. And then in the outer query, we're only grabbing 2 of them. So unless Postgres can optimize that, you're doing a lot of wasted work in doing that. So it would definitely be worth doing an explain on that to see if it's able to see that it's going to be throwing most of the work away. It might see that you have num is less than or equal to 2 and stop each partition after it gets 2 values. It might not be smart enough to do that, so you can use an explain to do that. Or you switch to using the lateral query and get the same results. So you have different options to. It really depends on the data set you have, though, that you're querying. You can't say this is efficient because it really depends on what's behind it. It can have a huge impact on it. So yeah, the Postgres docs actually have a lot of info on and examples on how to do window functions. So if you're interested in more info, I highly recommend you have a look at the docs. I mentioned that one query that we had looks a bit busy and a little bit ugly. So there's ways that we can try to clean up that query. What we can use is CTEs, common table expressions. So what we're doing here is we're specifying the exact same query that we had embedded in our select statement, and we're assigning it a name. We're saying, this query here, I want to call it user messages. And then in your actual query, you can reference user messages as a table, effectively. So now our select at the bottom is select full name title posted num from user messages, where num is less than or equal to 2. So this is much easier to understand. And we've pulled this out, which is, again, a bit more easier to understand on its own as well. This with clause, you can create as many of these functions as you want. They're just for this one query. This is one single query, so you're not storing these away somewhere. This is one query. You can have multiple defined subqueries that are used in the main select down at the bottom. Okay. It can also call itself. So if you create a named function or a named query at the top, it can call itself recursively. So you can actually look at hierarchical data and have it fetch information based on parent IDs and that. You have to be careful that it terminates, but it's definitely possible to do that. I haven't included an example of it because it is a bit, I still find it a bit difficult to understand myself, but it does work quite well. And it is, again, one of these powerful features that are available if you want to look at traversing hierarchical data in your tables.
If you've got something that a CTE that's common across the system, how can you make it reusable other than perhaps by having it boilerplate and using the editor to insert it?
That's generally what we have in our code is we would share that in the code and build it into a query. I'm not aware of the database being able to store an actual part of a query. But what you can do is you can take that query and you can create a view out of it, which then makes it accessible to everyone. So that's a possibility. What you can also do, if that query is expensive, you can create a materialized view out of it, which basically means you basically write a query and say, I want you to create a table on the file system with all the data that's part of this. And if any data that query depends on is updated in the database, your view is automatically updated as well, which means you always have the latest data of that query available on the file system, possibly indexed, which makes it very efficient to fetch that data at the expense of disk space. So that's generally the way that you would handle that. You would just create a view and use that instead.
Will Postgres in a recursive query happily chug away until you chew up all the memory in the stack, or will it?
Yeah.
No, can you set a limit on that?
Your limit is to make sure that your query has,
Oh, yeah.
has an exit
I'm
point.
just curious. Okay.
Yeah, I'm not sure. I haven't tried it myself, but I think it will keep going.
Yeah.
And,
It'll
Okay.
toss its cookies.
So that pretty well guarantees you can't use it in production.
Well, gee, man, you can
Well-
do that with any programming language that supports recursion. So you can't deploy Perl ever.
I've had plenty of Java programs that have tossed their cookies. It's looking forever.
My first day of CS, our professor told us, if any of you hand in work that has a recursive algorithm that never exits, you failed this course. Oh, question from Jim. Couldn't you also use an SQL function to share a query such as a CTE?
yes.
Well, as in like a stored procedure, yeah?
You could write a stored procedure for it as well, yeah. and call
Don't
that.
use stored procedures. They're hidden, you lose them, you don't realize they're there, they're evil. Put it in your code. This is because, sorry, I had so much evil come of stored procedure and triggers.
Oh, stored procedures are what DBAs love. Because
Yes.
They like to lock down tables. Oh, you can't insert into that table. Just use this stored procedure. Yes. There's one more thing that you can do with CTEs. You can actually, it's not just limited to selects. You can do updates, inserts, and deletes with them as well. And this is an example direct from the Postgres docs. Can you guys tell me what this query does?
Ah,
You guys see what it's doing?
Yeah.
So we've defined this moved rows as deleting a bunch of products. And Postgres has this concept of return star, which means return everything we just deleted as if you were doing a select statement. And then down here, we're doing insert into products log, select star from moved rows. So we're deleting all the rows from the products table that are between these two dates, and then we're inserting them into products log. So we're basically archiving a bunch of data from one table and throwing them into another, and we're doing it in a single query. Very simple, clean, simple query as well. So that's another bit of power that you can do with CTEs. Does everyone see that? I thought that was a cool example from the docs, so that's why I included it.
I would argue that that's something that should be done by a trigger,
It could be done by a trigger as well.
because the trigger sticks with the table, while your CTE sticks with this one example, but the other 10 examples don't have the CTE, so they delete stuff without archiving.
Yes, but I could counter that by saying it depends on who's archiving this data. If the database is archiving it automatically, that's one thing. But if you have a front-end interface that allows someone to say, I want you to archive my user messages from this date to that date, then this is something that might be useful for that. Yes?
I've used this with insert statements on two different tables. So where the key from the insert on the first table is required for the insert into the second table, you can double the insert up and just return the key value that's generated by the database for the next query to do its insert, and it does it all in one transaction, and it's one clean statement.
So that's common table expressions. I want to say a little bit more on these because there's some important information to know about common table expressions. Each one of these queries that you define up top are treated as its own temporary table. And that has some consequences. If your stored, or if your named query at the top ends up generating 1 million rows, and then in your query down below, you're fetching 10 of them, Postgres is doing a huge amount of work to generate those 1 million rows into a temporary table, and then you're pulling 10 of them out of there, and then you're throwing it away. So in that case, you really don't want to use a CTE. Postgres is not very good at optimizing across that CTE boundary. So if it's all in one query, Postgres can look at it, analyze it, and realize that you're throwing away most of that data, and it doesn't ever fetch it. But if it's in a CTE, it can't do that. So there's a bit of a wall between those two queries. So you need to be careful where you use them. Yeah, so if it returns a large number of rows, if you need all those rows, it's fine. If you're throwing most of them away, go with complex query anyways, and instead of trying to refactor it into using CTEs. So it's something to keep in mind on those. And before you throw away your CTEs, explain your query, and it'll tell you whether or not you have those issues or not. You can try it both ways, and if the explain comes out the same, you might as well use the nice, clean looking CTE instead of the large, ugly subqueries. Okay. So sticking with aggregates, we've been doing a lot of aggregate stuff, haven't we? There's another thing that we can sometimes do where we want to aggregate over a certain set of data in your result set based on a condition. So we've done it based on partitioning our data, but we can also do it based on a condition. Aggregate functions skip null values. So if you're counting a bunch of values in a column, it'll only count the rows that have a value in there. When you do count star, it'll get them all. If you do count title, and there is no title somewhere, you won't get all the rows. You won't get the total number of rows. So we can use that fact by sticking a case statement inside your aggregate. So we're counting up rows. If the temperature is greater than or equal to 7, I want to return true, else we return null. That means we're counting up all the rows where the temperature is bigger than 7, and we're skipping all the other ones. And we're also counting the total number of rows that we have, and we're grouping this by region. So if we look at our result set, we can see that Southwest England had the most days where the temperature was over 7 degrees. Doesn't sound very nice in England, does it? The highest temperature is 7 degrees, or 14 days over 7 degrees. My result set, or my data set, is actually quite small, and it's just in February, so it may not be that accurate. But 14 of the days out of 112 were over 7. So again, we're aggregating data, but we're doing it in a slightly different way. We're doing it based on a condition now, whereas before we were aggregating over a window, or we were aggregating over a grouping set. Now, this is really ugly. So in Postgres 9.5 had a lot of stuff, or maybe it was 9.4 actually. They've added a new feature that makes this much easier. And what we can do is they've added this filter function for aggregates. So we can do count star filter, where temperature is greater than or equal to 7. And we're going to assign that the name of over 7. And as you can see, we get the exact same data out of that. That looks a lot nicer. It's a lot easier to understand and parse than the case statement. But this is something that's always been possible, or at least I think the case statement has been there since probably 6.0. So it's been possible for a long time. Although it may not have been possible inside a account statement. But they've added this feature which makes it clean and easy to understand. You might also notice that I'm ordering by 2. I don't know if you guys use that at all. But that just means the second column, because I don't like having to write all that out in the order by, because I wanted to order by that column. One of the things that Postgres doesn't let you do is use that label in your order by statement. You have to use the full expression that you had in there in your order by. So I often just use numbers to say the second column is what we're ordering by.
It doesn't evaluate it twice when you do it that way, does it?
No, I don't think it does. It knows that it's already worked that out, and it's a pointer into its internal result set that it knows it needs to order by those values. Any questions on filters? Obviously, you can have as many filters in here as you want, as many aggregate functions you have in there. You can apply a filter to each one of them and do all sorts of stuff. JSON support. This is something that's been a huge thing, I believe, for Postgres. I think it first appeared in 9.3 or 9.4. At least the JSON-B support did. But sometimes, and a lot of times these days, people are choosing document stores, JSON document stores for their data, schemaless data. And we can actually do that quite easily in Postgres if you want to. And you can combine it with traditional relational tables as well. And the nice thing is you still get your rock solid data protection that Postgres gives you, your ACID compliance, transaction support, guaranteed that when you insert your data, it's going to be there or it'll tell you it failed, which a lot of other document stores don't have. Especially if there's something like a power failure or a system shutdown, you will potentially lose data. Whereas in Postgres, you never will lose that data. It'll roll it back, but it'll never be half in there. It'll either be there or it won't be there. And also what you can do is, because this is Postgres, you can add check constraints to your JSON blocks. So if you want to make sure that in this collection that we've created, we always want a specific key to exist in there, then we can put a check constraint in there that forces that to happen. And maybe this key can only have a set number of values in it. We can put a check constraint in there to offer that, if you want that. The point of these document stores is that they're schemaless and you can throw whatever you want at it. But if you need a bit of structure, Postgres still offers that to you. And also, you can still create indexes into your JSON. So you don't do an index on your entire JSON set. You might pick a key inside your JSON and index on that value. And you can query on that efficiently then into your JSON blobs.
It's only in 9.5, starting 9.5, isn't it?
Yeah, because it's the JSON-B support that offers all that. And you can still use SQL or SQL to query these documents, so you don't have to worry about MapReduce, which is very powerful, but also can be very painful to do simple things. So if you're comfortable with SQL, then you can get there and do this with Postgres. So there's two different JSON data formats or data types in Postgres. There's JSON and there's JSON-B. JSON is basically a text blob that's been validated as valid JSON when it goes in. Okay, that's pretty much the limit of it. It retains an exact copy of the JSON that you threw in there. So if it's all prettily formatted, that's how it stores it. If you have extra white space in there, it still keeps it in there. Spaces, tabs, whatever. It's an exact copy of what you threw in there. Key ordering is also maintained. Again, it's just a text blob. And duplicate keys. If you have a hash that has duplicate keys in it, it doesn't care, it'll leave them in there. However, if you run any JSON functions over it, it will process the JSON and it'll only use the last key that it finds. So you really shouldn't have duplicate keys in your JSON, but it will allow it in there. The drawback of this is that if you run any sort of JSON functions across it, every time you do it, it has to parse the JSON and look at the structure of it. So if you have a lot of records, that's a lot of work to do. So to counter some of those problems, Postgres introduced the JSON-B data type. And this is where the JSON is actually stored, instead of just a text blob, it's stored in a decomposed binary format, which means you're going to lose, or it means it's slower to insert an update because it has to parse it and format it into an internal structure. But when you do any processing on it, if you're including it in queries, it's much quicker for it to get to those data points in there. It supports indexing. It will remove any white space and key ordering and duplicate keys. All of that will disappear because it's just taking the valid JSON parts and stuffing it into its own internal representation. So what you get out will not be exactly what you put in. There's possible issues with Unicode escape characters as well. Unicode 8 works fine if your database is Unicode 8, or UTF-8, sorry. If it's ASCII and you're trying to put actual escapes in, Unicode escapes, what Postgres does is it converts those escapes into characters when it parses the JSON. And if it then tries to store it in an ASCII database, it's going to get an error because it's a wide character. So it means that if your database is in ASCII format and you try to insert a string like this, which is valid in JSON, it will convert that. And if it happens to be higher than that, that's the max value that you're allowed in ASCII, 256 or 6, I think.
5.
It'll be 5 on it, yeah.
127.
So that will be converted to the wide character, and then it'll say, I can't store this because I'm only storing ASCII, and it'll throw an error for you. It's not going to throw away the data. It's not MySQL. It's going to give you an error and say, this is not valid for me. But really, everybody should be using UTF-8 as their in their databases, unless you're in some other language or culture that uses a different character set. But UTF-8 covers pretty much everything, and you don't run into any problems then. It does mean that you will not get escapes like this out when you fetch the data. So it'll be converted to the actual character, and when you fetch it out again, you'll get the real UTF-8 character. Something to keep in mind.
Well, you mentioned ASCII, but I mean, if your database was, let's say, Latin 1.
That's only 256 characters.
Yeah, I know, but ASCII is just 128 characters.
Yeah, it's basically Latin 1. ISO 8859, I think, is the standard. It's very similar to, or it's pretty much the same as Latin 1.
Oh, it's just that you said 7F, so that's like 127, the del character, as opposed to, I know the UTF-8 would be multi-byte if it's over that.
It'll be the same with Latin 1. Well, however many characters are in Latin 1, if you try to insert a character that's bigger than that, if its code point is bigger than that, it'll fail. So it'll work as long as the character you're inserting or specifying an escape code for, as long as that fits into the character set, it'll work fine.
So if it was Latin 1, it'd be FF would be your.
Yes.
Oh, yeah.
My hex conversion rates are not very quick, so. But thanks for catching that. Yeah, this is if it's ASCII. Latin 1 is the same, is a similar issue though. Now, having said all that, if you're creating a new application using JSON in Postgres, use JSONB. It's, unless you're using a legacy application that requires key ordering, and I can imagine some old code that parses JSON manually with regexes to try and find bits of info. I'm sure you guys have all seen weird code like that.
No.
Unless you need that, I would suggest you stay away from the JSON type and just use JSONB binary format. So let's look at a simple collection. Basically, create a table, set a data type or a data column, and assign it as JSONB. You can set a not null on it so that you can't put an empty value in there. And you have a schemaless data set. You insert into the data column your JSON blob, and you fetch from that data blob as well. Really quite straightforward. You can create multiple collections, just give the table a different name, and you can have separate collections. Very straightforward. Now I add one thing, and I stick my ID in its own column and set it as a primary key. It'll get indexed. It's easier to query. And all document stores have a unique ID assigned to each document anyways. So that could be your UUID value that they quite often use. You can store that in there. In our work, we actually store the ID value in the JSON blob as well. But we always have those two columns, ID and data. And we generally only store one type of data in each. So if we store device information, so it might be a modem or a MAC address that's in there, and then the JSON blob is all the info that we have on that MAC address. Doesn't mean you have to do that. You can put completely different JSON documents with all sorts of structures in there. Postgres doesn't care. It just makes it more difficult for you to process it and query it if you're planning to query it. If you're just trying to store JSON and you're not going to query it, if you're just doing keyed access to it and pulling the whole thing out and throwing it somewhere else, then you don't have to worry about that. Just use one table and throw everything at it. So let's look at some queries and how we can get data out of a JSON blob. So I've got a bit of data here. We've got some products. We've got our ID, and the ID is repeated inside our JSON blob. We've got a name, and we've got some tags, and we've got a price at the end. We've got 4 products here. So if we want to query this with SQL, we have our data column. So we're selecting from data, and we want to get the name out of the hash. So we've got a hash in our JSON. Okay. So we want to get the key that is called name, and we use this arrow notation to get it. So if we're pulling that from my products where ID equals P1, we're going to get purple widget, which is our key here, purple widget. Pretty straightforward. So this arrow notation is what you use to walk into your, it's kind of like XPath, walking into your data structure. You'll notice that there's 2 arrows here. What that means is it's going to take this value that's here and it's going to flatten it to text. There's another thing that you can do is, what if we wanted the tags value? The tags is actually an array, a JSON array of values. So we use a single arrow here, which means we're getting JSON back. So we're getting JSON B in this instance that's returned. And as you can see, our output is now a JSON array of data. So if you want JSON back, use a single arrow. If you want text, use a double arrow. Does that make sense? Now we can go deeper as well. We can go right into our array, so you can chain these. So we have to use a single arrow here because we need this to return JSON so that we can call another arrow on it and get the second element in the array in there, 0-based. So we should be getting, we're doing P2, we should be getting green, and that's what we got out. So however complex or however deep your data structure is, you can walk into it using this, as long as you know its structure. Any questions on that? Yes?
When you flatten, say I was doing data dash arrow arrow price, am I going to get back a string of 12.50, or am I going to get an integer or a flattened integer? Or
You're going to get a string.
I'm going to get a string.
You're always going to get a string back.
Okay.
It's flattening to text, so it's going to be a text value. And I think in the next slide, you'll see exactly how we have to deal with that. So what we're doing here is we're returning our full data, but we're now using this in the where statement. We're creating a value in our JSON structure. So we want to find out all the products that have a price that's greater than $10. And exactly as Dave mentioned, data arrow arrow price gets us a string back or a text value, and we need to mask that to a real, which converts it to a decimal, and now we can compare it against another real value over there. You can call it numeric as well. You can mask it to anything as long as the content in there you know is going to be valid. Okay, and this returns us exactly the ones that we were after. Those 2 are the prices, or the 2 products that are over $10. So you can use these anywhere in your query. And this is exactly how you would index it as well. So if you wanted to create an index on the price field, you would create an index over that function call, basically. Internally, that's effectively an operator to Postgres, which makes it a little bit difficult to use from Perl. If you're using DBX class or things like that, you're basically taking data and applying an operator to it with this value, and that's getting your values out. But with DBX class, you're generally pulling out chunks of JSON. So, all right. Now, where things get a bit hairy is what if we want to find out all the products that are tagged as green?
Mhm.
Those values are in an array, so we need to reference them individually if we want to add them to our query like that, which is obviously not going to scale. This works, it gets us the values that have a tag called green, but what if we have 20 tags in there? Are we going to have 20 OR statements in there? It's just not practical to do that. So we have to find another way to query it. And here we can get to some of the JSON functions. What we can do is, if we want to use the power of SQL, we like things in columns and rows. So before, what we did is we took columns and rows and mapped them to JSON. We can do the reverse as well. We can take a JSON blob and split it apart into row data. So what we're doing here is we're selecting from our products table, our products collection, sorry. It's not a table anymore. And we're joining it against the results of this function call. It's JSONB array elements text. And we're throwing at it the data tags element. And we're telling it that we're going to label this as tags, and each item that's in that array is going to, the column name of that is going to be tag. Okay. Now we have to have this extra little bit on the end be on true. That's because we're doing a join. So we have to have a condition on the join. And all we're saying is we want to join on all records. So we're flattening it completely. So what we end up with this, if we just do ID and then the tag, which is tags.tag, tags is the result set, tag is the column name. What we end up getting is a table structure with the product ID and the tag that's in there. So we now have a standard table that we know how to query. So we've ended up from 4 products to 8 rows because each product has 2 specific tags attached to it. Does that make sense how we did that? So you can do that with very complex things as well. It just happens that this array has strings in it. It could be an array of hashes, which would throw out a hash entry in here with JSONB that you can then query as well. So you can go as deep as you want with it. It doesn't just have to return values. JSONB array elements text always flattens the values to text. There's another version of it called JSONB array elements, which will always return JSON. Now, if we used JSONB array elements here, we would get these results, but they would be JSON results, which means that they would have quotes around them, double quotes around them. Because in JSON, every value is quoted. Okay, so you have to remember to use the correct one in that sense. So this didn't get our results that we wanted, but if we change the query slightly, we can now add a where condition that says where tags equals green. So we're going to select data, which is the original data structure. We're doing this join where we flatten the array into a bunch of rows, and we're only returning the ones where we find a tag that is equal to green, and we get the exact data that we want. And it now scales to as many elements that you have in this array as you want. Does that make sense? Now that's still kind of ugly, actually. It's very powerful, but there's another cleaner way of doing this as well. This does the same thing as well.
Cleaner.
Cleaner? I did it. This is a new operator, which is a containment operator. So data is our JSON blob, and we want to find records that contain this. Now this is a JSON snippet, basically. And what we're saying is we want all the rows that have data that start with a hash and have a key called tags that has an array where one of the values is green. So it's looking at the structure of our data, and all of those things have to happen for it to match. So we're saying that this has to exist inside data. Does that make sense?
That could get really confusing for some of these. Like I get it now that you say it, but looking at it.
Well, we can simplify it.
That's why they give it an ice cream cone.
Yes, makes you happy. So we can simplify it slightly. What we're doing in this one is we're looking at the whole JSON blob. But really, we only care about the tags that are green. So we can instead apply the operator to just the tags. So we pull out with our single arrow notation, the tags, which is going to be JSON, and we want to make sure that there's a green one in there. So this returns an array. We want to make sure that that is an array that contains a value green. And that gets us the exact results that we want as well. So if you do have a very big complex data structure, you can arrow into it and then do a simple containment query afterwards. Does that make you happier?
A little happier.
A little happier.
I'm assuming as well, like if you have, like I kind of think of this as dereferencing.
Yes.
Is it, what happens if you try and dereference too deep to where there isn't a reference?
It'll just fail the condition.
It just fails the condition, it
will be
doesn't-
false, and it'll skip that row.
Okay.
So there's no, it doesn't auto-vivify. If you were worried about that. No, it doesn't do that, and it doesn't care if the key doesn't exist. It just has failed the condition.
Okay.
Or if you are trying to return data and you're going deep into a structure and it finds nothing, return null.
Okay.
So it does the same thing what you would expect it to do. It's not going to fail saying, no, that hash doesn't exist. Okay, any other questions? All right. When you work with this on the command line, it returns your JSON in a single long string. And we have JSON blobs that are like, I don't know, 500 lines long, lots of data in them. So I use JSON Be Pretty a lot to look at this stuff on the database. That's one thing that happens in Postgres. If you have a record that has, say, 5,000 characters in it, and you run it on the command line, all you see is a bunch of dashes across the whole screen. You got to page through 5,000 dashes before you get anything, and then you're still not going to see anything that's useful. So yeah, this is very handy. And again, you don't have to pass it data. You can pass it a subset, so you can do data tags, and it'll prettify just the tags for you. Really handy when you're debugging. Or if you want to write this out to a file somewhere that's going to be used somewhere else. Okay. So let's look and see what we learned. I think that's most of what I wanted to talk about. So we learned about lateral subqueries and joins. We did some stuff with correlated subqueries, aggregating rows into JSON with JSON Be Aggregate, where we were taking result sets and mashing them into JSON and returning them in single rows. Grouping sets, along with cube and rollup to do multiple group bys in a single query. We did window functions. We did common table expressions. We learned when not to use common table expressions. Filtering your aggregates, filter where, and a condition. JSON versus JSON-B, using Postgres as a schemaless document store, and extracting JSON arrays into rows to simplify our querying. So that's pretty much what we've covered. Do you guys have any questions on any of that stuff? Yes.
What sort of parts of that are sort of like, where's the boundary between things that are in an SQL standard and things that are?
The majority, Postgres tries to follow the standard as much as it can. Unless the standard doesn't support what it's trying to do, it'll do its own thing. A good example of that is the lateral query, subquery, is part of the standard. But if you use SQL Server, they call it apply. And it works the same way, but they use a different name. The standard calls it lateral. A lot of this stuff that I've done will work in Oracle as well. Maybe not the JSON stuff, but those grouping sets and the lateral support, the CTEs and all of that is very standard with the latest SQL standard. There's a few things that Postgres does that don't quite fit into that. And I think a lot of the JSON stuff is part of that because that's not part of the standard as of yet.
Just wondering about learning this kind of thing, that with the original SQL standard, when you, with the statements, you were essentially producing a program which you have to get into mind all at once, which was a challenge with the original SQL, and now all this other stuff has come in as well.
Yes.
Have you?
There's a lot there. We can go back to that first page where I showed all the different things that can fit into a Postgres query. There's a lot there, and the hardest thing is you often know what you want in your results, but you don't necessarily know how to get it. So you have to look across all the different ways of doing things. And this job that I'm working at now, I've been there for a year, and I've learned a lot of this stuff based on the work I've done there. Some of the work that was already done and some of the work that I had to do. So there's a lot there, but the difficult thing is knowing what to find and what to look for. I remember in university, I took a database course, and they taught us SQL by teaching us algebra, I think. One of them, the data sets or the relational data structure, I think was calculus, and the SQL query language was algebra. They have to bring everything back to math in university.
Oh.
But the SQL query language could be broken up into math effectively, into algebra. But with all these new constructs, I wonder how difficult that course is these days. But yeah, it's there's definitely a lot there that it does now. I'm hoping to show you guys a few of these things so that the next time you're faced with a data challenge, that you maybe think back, and I remember hearing something about that, and maybe use one of these ideas. If you're using DBX class, most of these things won't work directly in there because it's all about updating individual rows, fetching all the data from with a very simple where statement in it. Some of them you can kind of mash in there, but most of this stuff is for serious report writing and for really processing your data. And you're more than likely going to have to hand code the SQL statement. And you can still use DBX class to grab that, and you can even generate objects out of it by specifying temp columns. But it really depends on what you're after and what you're planning to do with the data. If you're generating a report, you might just throw it out as CSV, which Postgres will happily do for you. You won't have to do it in code. If you're using it for web application, it's useful to just let the database return JSON and hand that off to your web app and have it look at the data and render it the way it wants to. So there's the use for DBX class is more for standard relational setups and managing the data in there, inserting a record into, I created a new message and that gets entered into there. But fetching that data out, it's often more powerful to use the database to process that data for you, get you exactly what you need instead of doing 20 queries to the database to get little bits of information every time.
There's one thing, if you're trying to build up a complex query, or in fact any process, that it's nice if you can take individual pieces of them and verify what they do, and then gradually build them, put them together like Lego blocks.
Interesting that you say that, because that's actually what we do when we generate our reports. We have some really crazy SQL queries that can be many pages long, and if you look at the end results query, it's almost impossible to figure out what it's all doing. But these are generated by Pro modules. So we have a report module that does a lot of that heavy lifting for us, and we'll have a SQL statement that is in there. But inside there, you can actually, in your from query, you can pull in a SQL fragment from another PM file. So one report will have one PM file as the master, which might pull in 4 or 5 other queries from other PM files. And they may pull info or queries from below that as well. So in the end, you end up with a single query that might have 5 subqueries at one level, and those subqueries might do another subquery below that, and more aggregation and converting stuff to JSON. And in the end, we're getting a massive set of data that's all dumped into columns of JSON, basically, that gets thrown to our front end. And from that info, we generate a report on the front end. And some of those queries are incredibly complex, but by breaking them up into parts in our code, we are able to then reuse them and make them individually understandable. Because each one of those you can execute on the database and see the result it gets. And that gets included into the parent query. And it makes it a bit easier to follow that. So you can definitely do that in your code. You can't do that in the database. So there's going to be a bit of both sides depending on what all you're doing.
This is my complaint about ORMs. They're always built to work with the most generic SQL that you can write.
Yes.
And it's so frustrating when you actually want to leverage, you know, the strong points of whatever system you're using. Because I found even when you're not using anything out of the ordinary in the ORM, if you actually try and do the holy grails, completely switching databases without changing any of your database code, it never works.
No, it doesn't. So I just wanted to mention, there was a lot of questions about when these features were added. So I've listed a few reasons of why you should be using the latest. So I mentioned materialized views. So lateral was added in 9.3, it looks like. JSON-B support, 9.4. 9.5 has upsert. I didn't cover it today, but you can insert with a failure mode. If there's a duplicate, you can then do an update instead. And it's very configurable to do all sorts of amazing things that you can do with it. It's not just insert, oh, the file exists, so we're going to update the values that you're trying to insert. You can provide completely separate data and values, and it's very well thought out and pieced together. The grouping set's also 9.5. 9.6, you can now do full text search on phrases, which is, we're not using that at our new job, but I could have really used that at my old job. And the one that we're really excited about is parallel execution of individual queries. So we have a database server that has 24 cores, 48 cores. And if we're doing a really heavy import or query, one core is pinged at 100%. But with 9.6, that gets spread across all the cores that it needs or that it can use to execute the query. And as it mentions, it can help with sequential scans, joins, and aggregates. So that's, we just upgraded to 9.6, so we're just starting, we'll start to see the benefits of that soon, I think.
What are the approximate years of those?
9.3, I think, was 2012, so we're looking at 5 years ago. So
6 was just late last year, wasn't it?
Yes, 9.6 was fairly recent. They do have point releases in between, but they don't add major features in between. There's a lot more that was added. I just highlighted a few things that are important to me and that I think are useful additions that were in there. But a lot more was changed in there, a lot of optimizations, a lot better support for replication and all of that. When you look at the schemaless support, one reason that people still use other systems like Mongo and CouchDB is the way that you can shard across many systems. And that can be done in Postgres as well, but it takes a bit more effort to get that to work. So there's good reasons to use it in Postgres. There's still reasonable reasons to use other systems as well. Although we're moving away from them as much as we can. Because for us, Postgres is everything we need. It really fits our needs very well. So does anyone have any more questions? That's it for me, actually. I'm out of content.
Can I just utter some comments?
Go right ahead.
Oh, okay. First of all, I want to thank Toronto Pearlmongers for not dying. And I want to thank Cees, in part because I remember presentations that he made either at perhaps a YAPC or more likely at Toronto Pearlmongers meetings like more than a dozen years ago, which would have been some of the first Toronto PM meetings that I attended. And I found this talk particularly valuable because where I worked for 4 years, we used Postgres, and when I started there, I knew nothing about it. And after 4 years, I I learned some of the things that Cees talked about tonight. The one thing that I never could quite wrap my head around was window functions, but we only had one query that used window functions in the entire code base, and nobody else could figure that out either. So I didn't feel too bad about that. But I would love to be employed again in a place that used Postgres, because we never, during the time I was there, we never really made it up to past 9.2, particularly in terms of the new functionality. And so things like lateral, rollup, cube, JSON-B, those are all very interesting to me. If anybody has not already used with clauses, more formally known as common table expressions, I would really encourage you to try to delve into that topic, because when I discovered the value of with clauses, that's when I really started to understand how to structure queries. Because if you can think of a data munching problem that we would approach through Perl, we would probably use a series of hashes to get a certain result. And I often find that in Postgres, temporary tables are the equivalent of hashes, and with clauses are the easiest way to get a feel for setting up queries in the order in which we Perl trained humans think of them. Thanks.
Thanks, Jim. I guess I'll mention while we're all here that I do have a talk for next month. Olaf is probably going to give a talk on Modulicious and converting your app to it from other things. We do have an opportunity perhaps to get Yannick Perot or Yenzi on Twitter and ProMonks and such. He may be in town from Ottawa. So he may be on an irregular day, but he's going to come in and give a talk about things he stole from Node and put into Pro. So I got 2 more months, so we got 2 more months. Anyone? So we're good for a little while. Thank you very much. That was a fantastic talk. Thank you, Kate.
And thanks again for helping out and hosting.
All right. Cheers, everyone. Have a good evening.
Yeah, I've been looking at it.